Welcome to Envio Shipper Log. My name is Dimitri and today I'm going to show you HyperIndex version 2.31. The minor version goes quite big. And today, no live coding. Of course, if I can call live coding when I do this during video recording, because no big features, like no config changes, no new options, but this release is super important. And this release also is super big. And if you use a version lower than this one, I highly recommend you to immediately upgrade to 2.31 or even to like current latest version you're watching. For example, it's already 2.32. So yeah, I definitely recommend. And the reason is because we completely rewritten our logic, how we handle rollbacks on reorg. And this is important because previously we had a few edge cases when your indexer could get the corrupted data, and now it's solved. Like now we don't have for a month. Well, this was 2 weeks ago, but we this is it for quite some time. No reports for a lot of users. Also, it was solely tested. We added a bunch of test cases. We added our internal test framework. So this is much more reliable than before. Also, it got much more performant, and it also reduces the latency of your indexer, because when we write the data, we now update our internal tables to rollback when a rework happens in a much more performant way, and it will make your indexer faster at the head. So your user will get your data much faster now. And also our internal tables got smaller, so it will like a nice addition to get a little bit more space saved when you're developing locally or just when you're in Indexer. And another nice addition, besides the fact that this new system to track reorg and rollbacks allows us a new nice features in the future, especially to optimize our memory storage. And yeah, in memory storage, like we can make our indexer much more faster with this change in the future. And also what's important is that events processing counter, previously, if you were running two indexers with the same version, same code, there was chances that, for example, they went to different RPCs or hypersync replicas, and they got a little bit different data, and one indexer detected reorg and rolled back the few events, and another indexer didn't detect reorg here, and it immediately, for example, got valid blocks. And in this case, the event process counter could go off because it didn't decrement on rollback, and it was infinitely increment. So the first indexer, if it rollbacks 3 events and then index them again, it would have 3 more events in the counter more. And this caused some confusions where you could see, okay, I have 2 indexes with the same exactly code, but it has different events process counter. Does it mean the data is corrupted? Usually it meant no, but because of this feature, we couldn't really tell. And now events process counter is also rollbacked when we roll back the actual data. So it's going to be the same for this case for both versions, even if one of them rollbacks some events and another one doesn't. This is actually a valid case. So yeah, I think this part is going to be a little bit nerdy. I'm not the best person with explanations. But I'm going to tell you a little bit more about how we handle rollbacks in HyperIndex, so you know a little bit more context about the tool you're using. And first of all, it's important to know what reorg is. And yeah, I'm really bad at explaining, so I definitely recommend to read some articles if you don't know what reorg is. And let's begin. So HyperIndex, HyperIndex doesn't wait for a block to be finalized or anything like this. It tries to give you the most latest data on chain as much as possible. So it optimistically expects that a block won't be reworked, and this is an actual block, and it indexes the data it gets from the RPC or hypersync or any source you have, and immediately processes it. But then, for example, they get a next block, and for the next block we see, oh, a hash for the apparent hash for this block doesn't match the hash we indexed. This means we probably need to roll back. And yeah, this is called in HyperIndex reorg detection. And when we detect a reorg, we first of all finish currently processing batch. In parallel, we figure out to which block we need to roll back. For example, we detected a reorg on this block 6A, and then we, block for 5, hash for block 5 doesn't match what we indexed. Block for 4 also doesn't match. Block for 3 also doesn't match. Block for 2 matches. So it means we can roll back to block 2 and then re-index blocks 3, 4, and etc. And this is quite simple, but then we have a multi-chain indexers. Sometimes your chains interact with each other, sometimes they not. But for example, let's say your chains interact with each other, and it means that we have, for example, mainnet and base. And for example, on mainnet, you set some entities, then on base you read some entities set on mainnet, and something like this. But then we detected a reorg on mainnet, and it means that we also need to roll back base chain. And yeah, it gets a little bit more tricky in this case. And to solve this problem, we introduced such thing as a checkpoint. And checkpoint is is a serial where we track the order in which we processed blocks for every chain. And this is an internal thing, but now using this, we now can we can know in which order we processed the chains, even if it was ordered or another multi-chain. And this allows us to safely roll back all the blocks processed on base, which happen, for example, in between block 2 and block 6 on mainnet. And this is for reorg detection and filing where we should roll back. So when a reorg happens on one chain, for multi-chain, unordered, and ordered modes, it also might cause a rollback for other chains. So you need to be aware of this. And then when we do a rollback, we don't immediately delete all the data in the database from block 2 to block 6. No, we just create a diff in memory, and then when the progress catches up to where it was, to block 6, we write the data from the in-memory store with all this rollback diff plus all the changes accumulated from block 2 to block 6 after a reorg happened, and then all this diff writes to the database. So we and your users can get updated data without seeing a progress being jumping back and forth. For example, they saw some data and then it disappeared for some reason. This doesn't happen in our case, and I think this is really nice. And this is done by some internal check tables. You can see them in Hasura. Display their prefix by Envio checkpoints, Envio underscore history. So if you see them, please don't use them because they're internal and they're subject to change, but they're really important and they allow you to get experience where you don't need to worry about any reorg or rollback and just safely store data and have a really nice GraphQL API or read directly from database. Yeah, see you soon.